Greetings, everyone. My name is Sam Falvo, as it says on the slide. I have a message today which is probably going to simultaneously upset the people who are super minimalist about Forth and the people who are all pro object orientation about Forth. So I'm an equal opportunity offender today. Basically, these are the Forth distributions or Forth implementations that I'm currently aware of that I can rattle off the top of my head. I didn't even list color Forth there because I'm just kind of focusing on the syntactical Forths. And these are some of the object-oriented extensions that exist. And basically, this is a problem for one very important reason. When I'm at work and I'm giving a talk on Forth for whatever reason, like as some of you may have seen in the SVFig video collection, I have a talk that I gave on how I wrote my blog in Forth. The very first question, almost always by people who are unfamiliar with Forth, is there a standard market or repository of reusable code that I can just download and use? And typically, for most other languages, they all have object-oriented functionality to them such that you can just go off and download packages that you then install and you can just straight up use, just like that, out of the box. Forth, of course, doesn't have this because we have a order n squared problem when it comes to syntax language extensions. So, like I said, here's a number of Forth distributions, each of which have their own little peculiarities. These are the object-oriented extensions that I consciously can remember, each of which have their own peculiarities, and a lot of times there's a lot of religious wars about them as well, concerning, for example, is it object method or is it method object syntax? So here's a typical problem that you might experience with other languages, but in this particular case I framed it in the context of Forth. I'm writing a network-aware application, and for whatever weirded out reason I decided to use RetroForth. And on top of that, I decided that the object-oriented framework that comes with gforth, OOF, was a good fit. So I took the time to port OOF to my project. But then someone decides, you know what, I'm going to write a socket class, and it's written using swoop under SwiftForth. Well, shucky darn, I really want to use that class. I don't want to have to reinvent the wheel because I've got managers breathing down my neck or what have you. Time to market might be important for you, what have you. Whatever the reason, there's that desire to use that socket class. What do? Well, one approach is to port swoop to RetroForth and make sure that you use the socket class as it basically is. There are several problems with this. Number one, you essentially have to migrate most of ANSI Forth core word set to make that happen. The other thing that you need to do is you need to write proxies so that the swoop class hierarchy can then send and receive messages from the OOF hierarchy, and you end up having to write multiple intermediate classes and so forth. Not a good prospect in my book. The other approach is to rewrite the socket class in OOF for seamless integration with my existing code. But that requires that I have access to the source code by way of the license. So if somebody decides to say you have a non-exclusive license to use this code as is, then that pretty much locks me out from having to rewrite the code because that obviously violates the preconditions of the license. Or I could just ditch RetroForth and adopt SwiftForth and then live happily ever after. The problem with this comes if I've already shipped code. So that creates a support nightmare for the organization. And make no mistake about it, open source projects have to be treated like companies when it comes to customer support. Otherwise, you quickly find out you don't have any users. And the problems compound. What happens if I have that socket class that I wanted to use, but then say Doug Hoffman, who came up with the FML package, what happens if he wrote a GUI library using FML that I want to reuse? Well, which two of the three object systems do I discard? I say you don't need any of them. Just use straight up Forth. There's plenty of ways to use Forth that allows you to maintain encapsulation, inheritance, and polymorphism without having to use any syntax extensions. And I ate my own dog food. So basically, instead of just coming up here to the pulpit and preaching the holy word of forth, I decided that I was going to write a typical industrial scale application to demonstrate that these concepts are applicable. So I decided to write a video game because enterprise applications are absolutely boring. They're big, they're complex, they do useful work, but they're not very visible, they're not 100% hands-on, you can't really tweak it and actually observe what happens. And plus, object-oriented programming was invented to solve, at the time in the mid-60s, complex problems in computer simulations. Well, these complex problems were issues of modularity, encapsulation, how do you reuse code, so on and so forth. And games, of course, are simulations by definition. So you would think that a video game is an ideal candidate for object orientation. It turns out, based on my experience, that this is total hogwash. I found that I had substantially less code by not using a class-based code reuse mechanism. So I wrote a game called Equilibrium. There's about 550 colon definitions. There's actually a few more definitions over that. There's variables, there's create buffers, and so forth. Approximately 2,300 to 2,400 lines of code. This includes blank lines. Basically, if I have colon, whatever, the stack notation, and then the line beneath it is the one line definition. I did this basically to appease the majority of the people who basically said my coding convention was entirely too dense. But it's spread out in 16 modules, and of those, 10 modules are extremely reusable in not just other games, but also other applications, classes of applications as well. The one disadvantage is I didn't have enough time to write the artificial intelligence aspect for it, because basically I'm simultaneously learning rational trigonometry plus fuzzy logic to make that happen. But it's getting there, but it just wasn't done in time for this presentation. So it was conceived out of object-oriented analysis deliberately. I want to make this point clear. This code is not, disclaimer. I'll just go straight into the disclaimer right now. This code is not in any way, shape, or form intended to represent the tightest, fastest, most concise way to write forth code. It is, however, intended to convey a representative way of coding that you would find in most companies today. So I'll go back here. So instead of using the object-oriented implementation, I decomposed the problem using object-oriented techniques, but I implemented it purely procedurally and relying on relational algebra between the modules. And we'll see how that works. And this has the very distinct advantage that you don't need any syntax extensions for that. So basically, this is one of the simplest large-scale programs I've ever written. I've written several enterprise applications in the past using object-oriented languages, including Java, Ruby, and so forth. And those were fairly simple to write because of the object-oriented nature. But this actually took away the award, so to speak, of when it comes to writing simple code. Most of the changes that I made as the game progressed were kept very localized. In most object-oriented environments, what you'll find is a feature request comes along and you have to say, well, you know, in order to support this, I need to change this class here. In order to change this class, that means I need to update the interfaces of these classes, you know, and you basically end up with ripple effects. Ripple effects still exist here, but they're confined. They're much, much smaller. Debugging was absolutely trivial thanks to using test-driven development techniques. And what test-driven development means is you write your tests first, then you write the production code to make those tests fail. This is actually kind of important because as you write your tests, if you find that your code compiles without, when you expect it to fail, there's a good chance that you're shadowing a very important word in the dictionary. And I had only 2 multi-day debugging sessions in the 4 weeks that it took me to implement this game out of 2,400 lines of code, neither of which were due to stack imbalances, which historically has been considered one of Forth's toughest classes of bugs. I want to make that clear. Neither of them have been stack imbalance bugs. All right, so basically, before we get to that, I'd like to show you what the game actually looks like. Unfortunately, I couldn't get the game to actually run live on the Mac. It wanted to, but the SDL library on this kept throwing up all over the place because of 32-bit, 64-bit issues, and also SDL allocates objects that Mac OS doesn't really like, so you have to allocate an NS allocation resource pool or some such object like that. So what I did was I captured a video of the gameplay on my Linux machine. Yeah, is there any way to do these work here? Okay. So basically here I'm yeah. So here the game is launched. I'm the little white guy here. I wish I had my laser pointer. So I'm this guy right here. Basically the game is still over at this point. So now I just started. And I don't know if you can see this or not, but when objects collide, they actually create sparks. So like there's a sparking thing down there. So the goal of the game is to retain or acquire, depending on the random distribution of stuff, the highest score that you can imagine, or that you can within a finite amount of time. Now, again, because there's no artificial intelligence on this, we're basically simulating a gas in a finite container. But I don't know if you saw the sparks there. So each pixel of those sparks is a distinct object in the system, if you want to call it that. And squares with the little X's on them, those are people who have the highest scores. And that's actually a game bug. I call that comet mode. But once I get the artificial intelligence plugged in, that'll cease. But you'll notice that as I collide with objects, my score decreases. And that's where the name equilibrium comes from. When I touch another player, it divides our scores equally, the sum of our scores equally between us. So the goal is within 60 seconds to keep the highest score that you can. Obviously, when you're simulating a gas, this is ridiculously easy, so I'm just goofing around here. But the point of me showing this is there's actually 5 different kinds of on-screen objects. You have the border, you have your individual player, you have the sparks, you have the score, and then you have the clock. So all of these different types of objects in a typical class-based system, object-based system, will have a class dedicated to them plus at least one base class. So you basically end up having to write 6 chunks of code in order to realize something like this. Now these chunks of code don't necessarily have to be terribly large, but it's, the extra lines of code ends up being something that contributes to average bug rates. I forget who it was. I think it was Fred Brooks who made the observation that bug rate is dependent on the number of lines of code, regardless of what type of lines of code they are. So it's very important to minimize the number of lines of code. And here I'm shutting the game down. So let me go back to the game, or the presentation rather. So here's a typical class hierarchy describing what I was talking about. We have the scoreboard, we have the border, we have the timer, we have the individual car, and we have a spark. And all of these are viewable objects, right? So in a class hierarchy, what we basically are saying that a spark is viewable, a timer is viewable. Now, if it's a singly inherited language, like most object-oriented systems are, you run into the problem of where you have an object which is actually a member of multiple sets. So let me go ahead and show you how I wrote the viewable object. But before I do, I'd like to point out that the viewable module as written in a component environment applies to all viewable objects, period. One chunk of code that applies everywhere, universally. Which means that you basically have to write potentially very generic code. And that's exactly what we see here. So basically, I have this line here, which is defining a limit to how many objects that I can support in this particular table. I declare it in terms of cells because I use the technique of arrays of arrays, basically. I have, or parallel arrays, sorry. So I have certain fields which I maintain in separate arrays. I've got foreign keys, which I use to associate a viewable object with other viewable objects, or I'm sorry, a viewable object with other attributes of that object, which may or may not be related to other objects. I have a renderers column, which is used to hold execution tokens that call back into a specific object's rendering function. And then I have a table of colors because different objects may have different colors. As you saw, the score was white, whereas the clock was yellow, for example. And of course, I maintain a couple of records, number of records here. And the way this works is, the code is basically broken up into, I have some generic accessors, but as per my declarative coding style, when I say something is viewable, that adds it into a database table. So the way this works is, when I declare something is viewable, assuming that it does not exist in the table, and assuming that I have enough room, I will store these particular fields, and then I'll increment the number of records. And we're done, right? So basically, one-line definition, very succinct, and this coding style actually has the benefit that you can take any one definition out of the source code, and if you understand the overarching context, you'll understand what that code does. You don't necessarily have to read above or below the code like you do in other languages. So basically, I have this precondition here. The not exists is basically a word which declares a predicate. Here I'm basically saying that for all the records that are currently defined, we have no match. Very simple, right? And if we do have a match, then all we do is we update the renderer because that's the only field that is provided as input. I also do a lot of return stack manipulation, partial continuation stuff, but that's an implementation detail that's worthy of another talk, actually. But here's the crown jewel that demonstrates what I'm talking about. In the game, every loop iteration, I simply say draw. I basically invoke drawn, and once that word returns, I am fully confident, per my declarative coding standards, that every on-screen object has been drawn. And that's what this definition here does. Basically, for every defined object, we draw it. And the way we draw it is first we set the color, then we execute the render, right? So what we're seeing here is polymorphism in the extreme. We're also seeing common behavior for all objects of a certain class, of a certain type. And conversely, we have the opposite approach as well. We can declare that an object is unviewable, and the way that works is once we find it, we delist the thing from our local database, and we collapse the rows so that we don't run out of locally managed memory. So basically, we're seeing polymorphism plus another characteristic of components here, which happens all the time, locally managed memory space. So basically, we have code which applies to all viewable entities. We have locally managed storage, and the functionality is global over the entire set of viewables, right? So our module is defining a set in a mathematical concept, in a mathematical sense. We're not attempting to artificially model reality. We're attempting to model it mathematically. So as I demonstrated, each viewable knows how to draw itself. We use callbacks to do that. And what you're going to find is in most object-oriented environments, when you deal with polymorphism, you typically have 3, 4 methods that you declare as virtual or what have you, or an interface that typically has 3 or 4 methods. When you're dealing with components, your components are so micro-factored that you typically have 1, 2 at the most, and that's rare, 1 callback, and that's it. So there's no particular need to declare these extremely long classes or modules, if you will, especially if you're coding in Java, for example, where the syntactical overhead over what you're trying to do is just immense. That just doesn't exist. You just take the address of a word, you call it, and you're done. There's no need for artificial classes, what I call artificial classes. And of course, it supports common behavior. So inheritance, how does that work? Well, basically, there's two different types of techniques to achieving it. One is composition of functionality. The other is dependencies on modules, on other modules. And in either case, what you're essentially doing is a form of active database join between all these different tables. So we use these object identifiers as foreign keys. As you may recall in the viewables demo, I had that column there, foreign keys. That's actually what's used to associate a row in the viewables table with the row in punctual table, and so on and so forth. And we can actually, I gave some examples here, but I actually discovered a better approach to demonstrate. Sorry, I'm going to be doing this for a while. So here's the definition of a vehicle. This is what actually makes an on-screen little player guide that I showed you during the quick video. So what we're doing is we're declaring, we're saying, hey, this is an object. But then we're saying that the coordinates are completely random, but it's a positioned object. Then we're saying that it has a dimension, which is another aspect. We're picking a random vector and we're saying that it is a mobile object, so it's moving. It collides elastically with other players and with the border. And when it collides, we want to execute that word every time, right? So the kapow word in this case is a word that is responsible for taking the average of the two-player scores and redistributing. We also declare it as a player because there is a function in the code that says for all players, right? So we need a way to keep track of what is and is not a player. And of course, it is viewable, obviously, because it's on the screen. And we have a random color assigned to it, right? So basically what we're doing is we're creating this object as though we were going down to the local Radio Shack store and saying, you know, I want this, I kind of want that, and, you know, blah, blah, blah. And then you come up to the clerk and you say, here's the stuff, you pay for it, and then you bring it home and you breadboard it and it just works, right? This is a very different way of constructing an object in contrast to class-based object-oriented systems where you declare a mold in the form of a class. And when you instantiate this object, you're mass-producing this stuff by means of making casts or making molds of the object. Yes. Let's see here. So here's the definition for kapow. Can everybody see that? So there's a definition for kapow, and actually this is kind of an interesting point too, which I'll get to a little bit later. Is that some of these words actually take multiple inputs. They don't necessarily have to be of the same type. They just have to be compatible enough, which is actually an important distinction. So basically what I'm doing is I'm declaring a set of sparks. So whenever he collides, that's what generates the sparks. Here we're taking the intersection of the two objects. We're determining the centroid of that intersection, and then we're generating a random number of sparks. And in fact, here's a spark where I use a predicate to make sure that I have enough room for enough objects. But once I do, I'm creating a spark exactly the same way. So here's an object that is positioned, it's mobile, it's viewable. Right now they're always white, they're not colored. And it's punctual. And what a punctual object means is after a certain period of time, something happens. And it's always on time, right? So in this particular case, I cinder the spark, which means it exhausts it. And cindering the spark, so there's my random stuff. So cindering basically is the opposite approach, right? So This is hypersensitive. So basically, I'm saying that the object is no longer positioned. It is now immobile. It is hidden from display or unviewable, and then I destroy the actual core object. Right? So this is how I do basic resource management. It is manual. Forth does not have garbage collection, so it brings back ugly memories of C coding maybe, but believe me, it's actually not that bad. And then redistributed, what I do is I take our scores, add them, compute the average, right? So there's the code that takes the average, and then I redistribute amongst the two playing objects. The foreign key uniquely identifies everything that you would typically associate with an object. So in terms of, like, if you're using object relational mapper, that foreign key, it corresponds to the entity ID. I'm sorry? To see redraw, that would be in, I'm sorry? So I'm confused. Oh, you mean the drawing of the player itself? Oh, okay, yeah. In that case, what I do is, I have to find it here. So that's the description of the spark. Okay, so when we render, what we do is there's two possibilities. You can either be an empty square, or you can be a square with an X in it. And the way you know that you're a square with an X in it is if you have the highest score, as defined by this predicate here. So the body, basically we take the origin, we compute the extent of the extent of the rectangle, and then we actually draw the rectangle. And I don't really have that much time to go into the code for a rectangle, because at that point now we're bit banging. But basically this is the high level code. As you can see, it's at least as high level as you would find in a typical Java graphics application. Well, in this particular case I am, but keep in mind that the foreign keys are stored in a table, right? So if you have the foreign key, that's how you associate one table row with another table row, and they don't necessarily have to be synchronized with each other. Okay, so that was an example of composition. There are also dependencies on other modules. For example, the elastic module that I had made mention of is used to implement elastic collisions. Well, you can't implement elastic collisions without a transfer of momentum. And you can't have transfer of momentum without having mass and velocity, and you can't have velocity without being positioned. Right? Those are just basic laws of physics. So that's how you implement that style of inheritance. We'll actually see an example of that a little bit later on. There is a duality between forth words and Smalltalk methods, it turns out. In Smalltalk, message names have a global meaning, and they are scoped by type. And this gives you the opportunity to do duck typing, and duck typing in turn allows you to write your code in a more or less natural language inspired approach. It turns out that forth has exactly the opposite connotations, interpretations of what its symbol means, but it ends up being a dual because words are scoped by context, not by data type. And here we use natural language semantics to synthesize data types. So they're exactly the opposite. Which means that names and their execution tokens correspond to object messages. If you've ever coded in Smalltalk where you pass a message ID to another class for invocation on another object, this is something that you can do using just out-of-the-box forth. Definitions correspond to the actual methods. And the nice thing about this is for the polymorphism in your code is explicit. One of the biggest debugging problems that I have had with Java is I'll be debugging, and then all of a sudden, out of the blue, my code transfers to some other class, and I have no idea where this class is defined, right? And this is singularly relevant when you're dealing with domain-specific languages. In Forth, everything is early bound unless you are told otherwise. So there is much less vagaries when it comes to debugging. Thank you. So again, on the concept of interfaces and so on and so forth, modules define mathematical sets to which an object belongs. And as you can see from the composition code when we were constructing the player or constructing the Spark, we were saying that this was a member. Uh-oh. How much time do I have?
Wrap it up.
Wrap it up. Okay. I'm about...
You're about how long from your end?
Yeah. All right. Speed run. Okay.
Another 5 minutes or so.
Okay. Messages and methods modules define mathematical sets to which objects belong. They are viewable, elastic, punctual, reversible, etc. You can manipulate these any way you want. They collectively form abstract data types to which are in fact polymorphic. They're closer to Squeak Smalltalk's traits. Not very many Smalltalk languages have them. Use vocabularies to prevent namespaces. Module words are aware of sets. We already looked at that. These are the 6 design patterns that I detailed in January of this year, which actually enables all of this to happen. You'll find that most of your modules have cruddy interfaces, create, read, update, and destroy. This is an abridged class hierarchy representing what the game typically has, right? So we've got towers of power, what I call. So your robot or human player is a player, which is elastic, mobile, positional, right? So you end up with very vertical class hierarchies if you let this go out of control. However, with the component-based approach, you tend to end up with horizontal, flat dependency graphs. This rat's nest of wiring here looks complicated, but really all it's doing is tracing out your dependencies on other modules. You'll notice that there's 2 broad categories. I could take this group of 5 and make a whole new game out of it. I can take this group of 5 and implement new semantics for the game. And I only have a much shallower but single tower of power down on the far side there. So basically, I already went over most of this, but this is actually something to take note of, is that this approach, unlike object orientation, actually works exceptionally well on processors which are aberrantly slow with object-oriented code. There is one disadvantage, and that is naive module implementations have ON or ON squared behaviors because you're always doing table lookups. Difference between 8 and 100 on-screen objects on my game is 1.5 milliseconds, which is insanely slow. But there are tons of opportunities for optimizations. Object-oriented systems are themselves forms of premature optimizations. They kind of lock you into a design. Object references mix pertinent state as well as indices to other objects. Oracle has a name for those, whatever. But there are plenty of optimization techniques. Since a database is not a stack, rolling is acceptable. And if you do a roll, you have a probabilistic O1 access time, which means that you have constant or probabilistically constant access time. Bad code will thrash, though, which means you end up with ON squared behavior. Hashing gives you an improvement of a factor of n, where n is the number of buckets. And then you have log n stuff like trees, skip lists, etc. And so basically, I have an existence proof, 2,300 lines, that says this is a good coding convention. I found it stupefyingly easy to code, and it's a technique that may actually allow, for the first time in Forth history, a viable component-based market of reusable code. Thank you.
One slide back with your,
Oops, I'm sorry. Oh, I do have the repository for this is actually up in Bitbucket. Anybody who's interested, I will send out an email to the generals list, or you can type it down if you want. And then, of course, how many people here would be interested in me starting the game over, reading the blog, and explaining how I evolved the code and so forth? Okay, so we have a few hands here. So, okay. Well, thank you very much. Yes. Yes, I did. Yeah. Rational trigonometry. Rational trigonometry is a fairly recent discovery. The professor who came across it, basically rational trigonometry in its simplest terms is never take a square root of a distance and always use your sine squared. Okay, so basically when you do that, you end up with quadrants instead of distance, and you end up with spread instead of angle. And that has the advantage that you don't need transcendentals. So my game, for example, does not use any transcendentals for the AI logic. It basically, there are disadvantages, of course. So it's just another tool in a toolbox. But the big thing with the AI is that it's using fuzzy logic. That's really the new realm for me. Thank you. Oh, I need to.
Oh, the other question?
Yes.
This game sounds a lot like Maxwell's Demon.
I'm not familiar with it. But yes.
Yeah, get moving.
We need a hook. You can get a long action later on it.
There you go.
All right.
You stand right there.